Today our topic is angle measures in polygons. So our learning target is how can I find the angle measures in a given polygon? First off, some key terms. Vertex is the end point of a side of a polygon. So for our picture over here, the vertices would be A, B, C, D, and E. They're the endpoints of the sides. So then our sides would be AB, BC, CD, DE, and EA. So the sides are in blue, the vertices are in green. Interior angles are angles inside a polygon. So this would be an interior angle. So you can have an interior angle at each vertice. Exterior angles would then be angles outside a polygon. So if we extend one of these sides, so we could here extend A, and then this angle right here is outside of the polygon, so we call it an exterior angle. And then the last piece are diagonals. So diagonals are segments joining two non-consecutive vertices. So sides join two vertices, like right here we have side AB is joined by that segment, so that makes a side. However, if we join two non-consecutive vertices, so vertices that aren't right next to each other, we get what was called a diagonal. So now if you look at this pentagon, it's actually split into three triangles by its diagonals. We have triangle 1, triangle 2, and triangle 3. So every polygon can actually be split into different sets of triangles. Our first theorem for this chapter is polygon interior angles theorem. So the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180, where n is the number of sides that the polygon has. So any polygon can just be described as an n-gon, where n is the number of sides it has. So here in our example, n is equal to 6, so we can call this a 6-gon, or more commonly we call it a hexagon. If we go back to this first page, we had 5 sides, so we could call this figure a 5-gon, or more commonly it's known as a pentagon. All right, the corollary to this is that the interior angles of a quadrilateral, so 4 sides, the sum of the measures of the interior angles of a quadrilateral is 360. So that's just commonly known, just like with triangles. We know triangles are 180 degrees. We know that quadrilaterals, so 4-sided figures, are 360 degrees. So in example 1, we want to find the sum of the measures of the interior angles of a convex octagon. Now convex just means that all the sides, none of the sides intersect, is really what we're looking for. So here we have a nice 8-sided figure. 1, 2, 3, 4, 5, 6, 7, 8. That's an octagon, 8 sides, and none of the sides overlap. So a non-convex figure would be something like this, where the sides overlap. So right here, this side overlaps with this side. So that's a non-convex figure, so we are not working with those. We're working with this type. Okay? So we want to know what the sum of the 8 interior angles would be. So we're going to use our formula, which says n minus 2 times 180 degrees will give us that number. We have 8 sides, so n is 8, so we say 8 minus 2 times 180. 8 minus 2 is 6. We do 6 times 180 and we get 1080. So there are 1080 degrees in the interior angles. Example 2, the sum of the measures of the interior angles of a convex polygon is 900 degrees. Classify the polygon by the number of sides. So again, we're using that equation formula, 9 minus 2 times 180. But now we don't know n, but we do know that the sum is equal to 900. Solve this equation. We want to undo this multiplication with dividing by 180 on both sides. We get, this cancels out, so we're left with n minus 2 equals 5. Undo minus 2 with plus 2 on both sides, and we get n equals 7. So we want to classify the polygon by the number of sides, so we could call it a 7-gon or a heptagon. Both answers would be correct. Example 3 on the back of your paper. Use the diagram to find the measure of angle S and the measure of angle T. If we look at our diagram, we have these congruent markings. So the measure of angle S is equal to the measure of angle T. So we can give them both the variable x to represent the value. First off, we want to know what are these going to sum to. We count the sides, 1, 2, 3, 4, 5. We have 5 sides. So when we find the sum, n minus 2 times 180, we're going to put 5 in for n. 5 minus 2 is 3 times 180. 3 times 180 is 540. So all 5 of our angle measures are going to sum to 540. So we can set that up. We take our our angle measures that we know, 93 plus 156 plus 85, and then 2 x's, so we can add to that 2x equals, and our sum is 540. Add like terms, 93 plus 156 plus 85 equals 334. Still adding 2x equals 540. Undo the positive 334 with minus 334. We get 2x equals 206. Divide both sides by 2 to get x by itself. We get x equals 103. So we can say that the measure of angle S equals 103 degrees and the measure of angle T equals 103 degrees. Last example, along with a new theorem, Polygon exterior angles theorem. So now we're working with those outside angles. The sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So no matter how many sides the polygon has, it could have 3 sides, 4 sides, 5 sides, 6 sides, and so on. It's always going to be 360 degrees. So in our example, measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5 would equal 360 degrees. So if we look at our example, what is the value of x in the diagram shown? We just want to sum up all of our exterior angles and set it equal to 360 degrees. And now we can solve for x. Add like terms. 2x plus x is 3x. 67 plus 89 is 156. Undo plus 156 with minus 156. We get 3x equals 204. Divide both sides by 3 to get x by itself. We get x equals 68. Find that answer up here, and it is B. X equals 68. That's all the notes that I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.